Welcome to Mrs. Neller's notes for her pre-calculus class. These are the notes for section 2.5, day 1, entitled Transformations of Functions. And today we're going to talk about the first 3 objectives. We're going to talk about vertical and horizontal shifting of a graph, as well as how you can get graphs to reflect around the x or the y axis. And we're going to talk about all different kinds of transformations in this section, and shifting and reflecting are just a couple of them for today. And understanding these characteristics helps us understand graphs of a function a lot better. And if we understand the graph better, we understand the function better. And if we understand the function, we can understand the graph behavior. So we're going to talk about shifting, reflecting, and stretching for our 3 types of transformations, but we're going to save the stretching for the next lesson. Okay, vertical shifting is the first concept we're going to talk about, and you should be familiar with this concept. So we have 2 questions for you. What mathematical operation do you perform on the function f of x equals x squared in order to move it up 5 units on the y-axis? Now you should know that this function, f of x equals x squared, that's just a parabola. It's going to open up. Its intercept is going to be at 0, 0. So how do I move that graph up 5 units? And hopefully you would know that you have to add. You'd have to add 5 to the end of that function. And then alternately, what mathematical operation do you perform on the function of f of x equals x squared in order to move it down 4 units on the y-axis? Again, same function, still the same parabola, it's opening up, its y-intercept is at 0, 0. So if you want to move that down 4 units on the y-axis, hopefully you know that you need to subtract. So you would need the function f of x equals x squared minus 4. So basically that's changing your intercept. It's changing your y-intercept. So a vertical shift is either going to move your whole graph up or down, however many units you're adding or subtracting on at the end. And here's your book explanation. Okay, so if we're adding plus c, which is just an arbitrary amount, then that's going to move the whole graph up c units. And if we have the function minus c, that's going to move the whole original function down c units. So here you have the 2 pictures that are demonstrating that, or illustrating that. Okay, so now in example 1, we want to basically take that function, that original function we had, f of x equals x squared, and we're going to use it and the knowledge that we now have of vertical shifting to graph A and B. Now there's a couple ways that you can do that. Okay, before I get started, I'm going to make a table of values for this function that they gave us, f of x and x. Okay, so I have f of x equals x squared. So if I just start at -3, -2, -1, 0, 1, 2, and 3, I'm just going to make a table of values for that x squared function. So I'll have 9, 4, 1, 0, 1, 4, and 9. So that is my basic y equals x squared parabola. It opens up, its y-intercept is at 0, 0. You can see that right here. Okay. Now, you, on the previous slide, hopefully you observed that if I'm going to take that original function, that x squared, and I'm going to add 3 to it, it's going to shift my graph up 3 units. So now we could do this 2 ways. We could go to our graphing calculator, we could type in this function, we could make a table of values and graph it. But the skill we have to get a little more practice with today is thinking, how can I just modify this existing table of values that I have written down to change it to a table of values for this new function? without having to go to my calculator. So if I make my new table of values for part A, I'll still have x, and I'll still have f of x. And let's just go from -2, just to save time when we're graphing. Okay. Now I'm still going to use those same input values. Those are the same input values I had here in my original function, that x squared function. And if I want to shift it up 3 units, then what will that do to my y values that I get out? And hopefully you're thinking it's going to add 3 to every single one of those y values that I get out, or those f of x values. And that's exactly what's going to happen. If you go to your graphing calculator and you type in x squared plus 3, and you look at your table of values, you will have 7, 4, 3, 4, and 7 for the values from -2 to +2. And if we look at our original -2 value, had a value of 4. Now my -2 has a value of 7. 4 plus 3 is 7. My -1 had a value of 1. Now I have a value of 4, because 1 plus 3 is 4. And it's plus 3 because I'm adding 3 onto the end of the function. Okay, so basically what we're doing here is we're adding 3 to the y value. That's what that function does to my table of values, and that's how it adjusts the graph. Okay, so then if I went ahead and graphed this, I need to draw in my axes here. Okay, go -2, 2, 3, 4, 5, 6, 7. -1, 1, 2, 3, 4. 0, 3. And then use your knowledge of symmetry to plot those other points. There's our parabola, shifted up 3 units from the origin. And then same thing for part B. If I'm going to graph h of x equals x squared minus 2, I could go to my graphing calculator, I could type that equation in, I could get a table of values and just plot the points. Or let's try and use our knowledge now of shifting, that vertical shifting, so that we can make our table of values based off of this original function that we were starting with. And again, to save time, I'm just going to go from -2 to +2. And now this function is taking that original x squared function and it's subtracting 2. So I can move the whole graph down 2 units. So here I'm actually going to subtract 2 from my y value. Oops, not 4, from. From my y value. Okay, so my original -2 y value is 4, so now I'll do 4 minus 2 is 2. My original -1 value was 1, minus 2 is going to be -1. 0, 0 is going to be -2. And then the pattern will repeat because it's a parabola. So again, if I graph this, it should move that parabola down from the axis of symmetry. So -2, 2, -1, 1. I think I said I moved it down from the axis, but it's going to move it down from the intercept. Oops. Hold on. Putting the wrong points there. Okay, let's try this again. Okay. -2, 2. There we go. -1, -1. Okay. 0, -2. There we go. Much better graph. So I know where I traced my x-axis there is kind of a little hard to see, but you can tell that the graph is shifted down 2 units from the original y-intercept of 0, 0. And thankfully on this next page we have a nice, pretty graph that the book constructed. So our first function moves the graph up 3 units, and our second function moves the graph down 2 units. So you don't always have to just rely on your table of values in your calculator. You can use this knowledge of graph behavior so that you can construct the table of values on your own. Okay, now horizontal shifting is going to move the graph to the left and to the right. And this isn't as intuitive as the vertical shifting. Vertical shifting, if you want to go up, you have to add. If you want to go down, you have to subtract. But now with the horizontal, it's a little bit different. So what mathematical operation do you perform on the function f of x equals x squared in order to move it to the right 2 units on the x-axis? Now the actual operation that we're going to be performing, you'd think if you want to move it to the right, you have to add. But actually, we're going to subtract. Because here, if we want to move on the x-axis, I have to do that subtraction to my x value. So I would have to do x minus 2 squared in order to move the graph to the right 2 units on the x-axis. And then to move the graph to the left 6 units, you'd think if I'm moving it to the left, I'd have to subtract, but actually you add. And again, we're adding onto that x value. So I have to add inside my parentheses. So horizontal shifting is a little bit opposite of what you would intuitively expect. Instead of adding to move to the right, we subtract. And instead of subtracting to move to the left, we add. And we have to think of it as doing it to that x value. So we have to think of it as being in parentheses with our x variable. And here again is a table that your book has that shows this concept. So in order to shift the graph to the right, I have to subtract from my x value. And here it's depicted in the picture. And in order to move the graph to the left, I have to add inside the parentheses there with the x. And that's depicted in the second picture there. So again, it's a little opposite of what you would think. So again, I'm going to construct this original table of values that I had before for the x squared. And let me still do from -3. To 3. So we'll have 9, 4, 1, 0, 1, 4, 9. Okay, so that's the original table of values for this f of x equals x squared function. Again, that's my basic parabola. It opens up. Its intercept is at 0, 0. And now I want to graph both of these, part A and part B. And let's try and use that knowledge of our shifting, of our horizontal shifting, in order to construct our table of values. Because again, I could go right to my graphing calculator, but let's see if we can apply this knowledge that we just talked about. So here, if I have g of x equals x plus 4 squared, I'm adding 4 inside the parentheses here. So that means I'm really going to be subtracting 4 from my x values. So if I'm going to make my table of values, if I originally wanted to start from like -2 to +2, now I'm going to start from, originally from -2. Originally that -2 value got me a 4, but now I'm going to subtract 4 from that x value. So if I'd like to start at -2, subtracting 4 from that will get me 6. So if I substitute in -6 to this function, that's a -2 squared, which is 4. So now my y values from my original function are going to stay the same, but my starting values for my x, my input values. Those are going to change. So then if I wanted to originally go to negative 1, 1, now I have to do the negative 1 minus 4, so that's a negative 5. And then I also was at 0, 0, but now I'm going to do 0 minus 4, so that's negative 4. And then I would be at 1, 1, so I'm still going to get 1 out, but 1 minus 4 is going to be negative 3. And then I would have been at 2, 4, but 2 is where I originally started. Now I'm going to subtract 4 from that, so I'll be at negative 2. Drawing my axes again here. Try and draw them neatly so they stay on the lines. Okay, so now when I graph this parabola, it should be moved 4 units to the left. So I'm going to go negative 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. And then negative 5, 1. Negative 4, 0. And then use your knowledge of symmetry to plot those other couple points. And notice that my graph didn't move up or down at all. It just moved to the left 4 units. It's not starting at the origin anymore. Now it's back 1, 2, 3, 4 units. That's where my vertex has moved to. And we can use the same knowledge, the same skill to help us make a table of values for our h of x function, which has x plus 2 being squared. I'm sorry, x minus 2 being squared. So what's that? That is going to do when I have that x minus 2 inside the parentheses. I'm subtracting 2 from my x value in the function. That means my graph's actually going to move to the right. So that means that what I'm going to do in my table of values is that I'm going to add 2 to the x values in my table of values. Okay, so just for simplicity, I'm still going to go from negative 2 to positive 2. So I'm still going to have 4 and 1 and 0 and 1 and 4. They'll be my output values. But now instead of starting at negative 2, I'm going to add 2 to that, since that's my x value, and I'll be starting at 0. Negative 1 plus 2 will be 1. 0 plus 2 will be 2. 1 plus 2 is 3. 2 plus 2 is 4. So there's my table of values. That's going to get me my new graph. That's going to be shifted 2 units to the right. So 0, 1, 2, 3, 4. 1, 1. 2, 0. And use your knowledge of symmetry to help you plot those other points. And there you can see the graph doesn't move up or down at all. It just moves 2 units over to the right. That vertex moves 2 units to the right. So again, you can graph these in your graphing calculator, but once we have this knowledge of how a function, the construction of a function, can affect the movement of the graph, we can also use that to help us graph and make our table of values. So here's the nice book pictures that go along with the graphs that we just did. All right, and the last concept we're going to talk about today is reflecting. And we're going to reflect a graph over the x-axis and over the y-axis. Now, this concept can be a little trickier, okay? If I want to reflect this original function, f of x equals x squared, if I want to reflect that over or across the x-axis, so if we think of our original graph here, here's my original parabola, okay? I want to reflect it across the x-axis. So here's my x-axis here, okay? That means I want to reflect it so that it comes down here. So I want that x-axis to be acting like a mirror. And hopefully you're thinking right now, oh, in order to do that, I would have to make the function negative. So this is the function that we would have to have. Negative x squared. So it's kind of like you're multiplying by a -1. Okay. And then for the other question here, what mathematical operation would you have to perform on the function f of x equals 2x? So now it's not that x squared anymore. It's f of x equals 2x in order to get it to reflect over or across the y-axis. Okay, so kind of changing things up here just for this example. Okay, if I have this function, f of x equals 2x, that means I start at 0, 0, I go up to and over 1. So I have a line with slope. Now I want that to reflect across the y-axis. So here's my y-axis. That means I want this to act like a mirror. So if I put a mirror down there, then I would have this as my new graph. So what do I do in order to get that to happen? And you're still multiplying, and you're still dealing with negatives, but you're just doing it to the x values. So we would want this function. So I'm still multiplying by a -1, but I'm doing it to my x values. And in the first one, when I'm dealing with the x-axis, I'm multiplying it to the y values. So again, it's kind of like an opposite concept. If you were trying to reflect over the x-axis, you multiply your y values by -1. If you're trying to reflect over the y-axis, you multiply your x values by a -1. So let's take a look at this in a little bit better clarity when we deal with our examples. And here, this is the chart that the book has to explain this. And they do a nice job as well of writing the function. So if you're trying to graph y equals negative f of x, that's going to reflect across the x-axis. Because remember, this f of x, that's really like a y. So you're multiplying the y by -1. And then if you're going to graph y equals f of negative x, that will reflect it across the y-axis. Because again, you're making that x in the function negative. And these are really good pictures to show the reflection. So this is being reflected over the x-axis. This other one's being reflected over the y-axis. So that table in the book does a really nice job of summarizing that information. Okay, so then let's graph each of these. Now again, for this first one, we have our x squared function. For the second one, we don't, but just to save time and space, I'm just going to make our table of values over here. Now, if I started with my x squared function like we've worked with in all of our other examples, I'm going to go from -2 to +2. And now traditionally, I would put in that value and I would get a 4 out. But because I've got that negative there, I'm going to change my y value. I'm going to multiply it by -1. And in my other table of values for just plain old x squared, if I put -1 in, I got a +1. Now it's going to be a -1. 0 is going to stay the same, 0 and 0. And then my pattern will repeat down here. So when I had just f of x equals x squared, these were all positive values in my y column, or my f of x column. Now they're all going to be negative. So this is kind of, again, that concept of multiplying the y value in your table by -1. So let's graph this. That line's a little sloppy there, but we're going to go from -2, 1, 2, 3, 4 to -4. -1, -1. 0, 0. Okay. So just by multiplying by a negative, that flips that original graph upside down. So now you have a parabola that opens down, which again is a concept you should know because that lead constant, that lead coefficient is a negative. Okay, now for my other graph, again, this equation is a little bit different than the one we've been working with. It's not x squared. Okay. Here we have to deal with a half a parabola that's kind of opening up on its side. So here I'm just going to pick some values and substitute them in. Now, originally, if I took the square root of x, that would be a parabola that opened like this. So if I want it to reflect over the x-axis, it would have to come down here. If I wanted it to reflect over the y-axis, I'd have to come up here. Now, I want to pick nice numbers that I know will go into this function. So I'm going to pick 0. I'm also going to pick a -1 and a -4 and a -9. Now, why would I pick those values? I want to pick those values because if I put in a 0, square root of 0 is 0. If I put in a -1, then I have a -1. That makes it a +1, which I can take the square root of. Same thing for the 4. If I put in a -4 here, I'd have a -4, so that's a +4. Square root of that is 2. Same thing for the 9. I'll get 3 out. So now when I graph, I highlight my axes here. Okay, so I'm still starting at 0, 0, but then I'm going to go -1, 1, -4, 2, -9, 3. So this graph then reflected across the y-axis. Because originally, my original function that if I started with f of x equals the square root of y, or I'm sorry, square root of x, that would have gone over here. Now it's been reflected across the y-axis. So what that did was it changed all of my x values. It's like I multiplied my x values in my table by a -1. Okay, and there's the nicer book graphs, in case mine weren't neat enough for you. But here again, you can see reflection across the x-axis and then reflection across the y-axis. So, one last concept before we end today's notes. What happens if you combine some of these transformations together into one problem? Now, we've been working with this function for 5 of our 6 examples, this f of x equals x squared. And our table of values for that, it's going to be the one that I've written several times now. Okay, we have 9, 4, 1, 0, 1, 4, 9 for our values. Okay? Now, here's what you really want to be able to do. This is the skill that you should be able to do. You should be able to take this original table of values and look at this function and construct your new table of values for this new function without using your calculator. Now, there's 2 things that are happening to this function. That x is being subtracted by a 1, and the whole function has a 2 that's being added on at the end. Now that 2 that's being added on at the end, that tells us that the whole graph is going to move up 2 values. So that means that I'm going to have to take all my y values and I'm going to have to add 2 to them. So then over here, I'll have 11, 6, 3, 2, 3, 6, and 11. And then this x minus 1 squared. Remember, when it's inside the parentheses, when that operation is inside the parentheses with the x, it's kind of doing the opposite. So that subtracting 1 means that the graph is actually going to move to the right 1 unit. So that means I'm going to take all of my x values and I'm going to add 1 to them. So then I would start at -2, -1, 0, 1, 2, 3, 4. And you could graph both of those functions in your graphing calculator. You would see the original parabola, and then this one, when you graphed it, it would move it up 2 units and over 1 to the right. And you can see that as well. Our original vertex was 0, 0. Now this vertex has been moved up 2 and 1 to the right. So these skills are really important to help us understand how functions are constructed and how it affects the graphs. And we're going to be dealing with transformations of all different kinds of graphs as we get further into the year. We'll be dealing with sine and cosine and tangent graphs and their shifts and their graph behavior. So really make sure that you understand these concepts now and practice these concepts in the homework. And if you have any questions, come on in and see me.